Welcome to this presentation. I'll just try if I can finish it in 20 minutes. Okay. Welcome to my presentation. So you can see my topic is on predicting stock price using graph theory, machine learning, and deep learning models. So this is a research paper. I just tried to implement something similar to them. Yeah, the goal was to implement this work and extend it, right? Okay, so what is the problem of this work? So yes, the problem is predicting stock prices. I mean, predict correctly, not just predict correctly, right? So is it possible? Now, there is a theory called efficient market hypothesis. What does it say? It says that at any moment, stock price reflects all of the variables related, and it shows the fair price. And you cannot predict consistently the price, and you cannot beat the market. Okay, so there are many portfolios or investment strategies. Those are built on this, right? However, let's say some other opponents, they believe stock prices vary from their fair market values, and it is possible to beat the market. Okay, probably not consistently. Anyway, the previous consensus was that it is really difficult or close to impossible to predict. Now, because we have more data, we can collect more data. We can collect various types of data, and we have the technologies to predict better. So now we are using these technologies to predict it, and hopefully we get better result, right? So when we predict, how do we predict? Usually, the prediction usually happens that we select some stock, some proper selection of stocks, and then within a time period, we predict, okay, this is the time period, this is the predicted price, right? And what we use? We usually use statistical calculation, statistical measurements, and then prediction, and then also use machine learning and deep learning, right? Now, what this paper has done, this paper has gone just one step more. It used spatio-temporal relationships among the different stocks and then predicted the price. So to understand the spatial relationship, it converted the interactions or relationships among stocks into graph, and then the connections and correlation. That's what it utilized, right? Now, temporal is time, right? Historical time prices that we usually use for sure for the prediction. So what are other works in stock price prediction? I think people use many different models, right? Just ARIMA, the traditional statistical model. And there are some Holt-Winters, some LSTM, some support vector machines, and Bayesian analysis. These are some, right? And it is seen that LSTM, or LSTM and SVM, they usually work well. Now, what this paper has done, as I told before, it also used graph-based approaches, represented the stock interactions as a graph, as you can see in the first image. So graph, and then interactions, there is some age, and sometimes we also put some weight on it. And then it used some graphical convolutional neural network and convolutional neural network combo to predict stock price. That's also, I also did similar because I'm trying to simulate the work. Anyway, so this is the methodology that I used for this or for my work thing when I was trying to implement the same thing and also trying to make things better or extend it, right? So, okay, yeah, the first step, data collection, right? So data, In my case, I used data, scraping data from Yahoo stocks. That's the stock prices, right? Now I used to use another data set from Yahoo, just some other data set, but eventually I did scrapping myself, and also financial news data, some data set from the Kaggle. So like any or most data analytics prediction problem, the next step is understanding the data and make it improve it. So I used interpolation treatment with the null values and trying to understand if the data is good fit uh, for my analysis or not. Okay, that is one other thing that I did here. So especially for the previous data set that eventually I abandoned, I think I did more on that, aligning the time or date and taking the specific range and make sure that data exists uh, for all stocks for the duration and for every single day. So eventually I scaled, but I think that probably was challenging. So I tried try an alternate approach. And then in terms of data, yes, I think I need smaller data. I think very simple things. All the data set. I just need date and closing price and stock ticker, right? But in the Yahoo Finance or the data set that I used before, it had other prices, right? Open prices, adjusted closing prices, and I believe in terms of Yahoo, you can find out some RSI or some other indicators or many different data, but I just need primarily I need ticker, closing price, and the date. That's the primary thing that I need. Adjusted closing price, sometimes it may be useful. And let me see, in some experiment, I probably could get benefit by using the open price for all of them and try to do some predictions on that. But in general, closing price is used, right? Okay. So after I selected the data, then definitely the graph generation, the stocks, their correlations, and then create some data. So I can see that Pycharm, Spearman, Kendall correlations, and then creating those graphs, right? And then also the financial news data, I created those graphs. And then after I have the data and all the graphs created, now the modeling, right? The paper that what it used graphical convolution network and convolution neural network combo as a group and multiple set of this group. So I tried to imitate something similar, and looks like there are some technical challenges or implementation challenges. So the closest I could get is graphical convolution network, convolutional neural network, and then MLP. The paper also uses MLP, but after a couple of blocks. But I just GCN, CNN, and then MLP. That was the closest that I could get. Okay. Now another thing is, okay, I'll come back to the comparison later. For now, let's see. And other modeling approaches that I used is the just GCN and CNN. GCN, it has multiple layers in it, right? And deep graph NN, actually it's deep graph CNN. I need to update the image. GCN plus LSTM, that was one of the goal for me to implement, but I did not do it yet. And okay, this modeling and the data, I execute my model on the data, and then I predict it, right? And for predicting, I try to get as close prediction as I can get, right? For this, yes, platform, to some extent, it depends. I think how fast you can get the result. Sometimes it's helpful to use the right platform, right? Anyway, and changing those parameters, definitely hyperparameter adjustment. I try to go as close result as I can. And then eventually there's a performance metrics like the paper. I also used RMSE, root mean square error, mean absolute percentage error, mean absolute error. So these are the metrics that I used for the performance, and I also compared my result with the paper. Okay, so modeling stocks into graph, that's sort from my work. Okay, so Pearson best, if stocks has a correlation greater than 0.5, then there is an edge, otherwise not. Spearman, if the correlation is greater than 0.4, then there is an edge. And the candle tau, if the correlation is greater than 0.3, then I create this candle, then edge, right? So Spearman and the candle, those also do the nonlinear relationships, right? And the financial news based. Yes. If any news article mentions two stocks together, create some edge with weight 1. If another article mentions the same two stocks, then we increase the weight. The edge is there, right? That's how we create the graphs. Now, in terms of data set, eventually what I used it from the Fortune 500 companies, 28 stocks I ended up using because I wanted to use 30, but I think Yahoo stocks, Yahoo Finance did not have data for 2. Okay, sure. And the data set 2017 to 2019 for 2 years. And news data set, yes, Yahoo News articles, couple thousands. Okay, it looks like it's a conflict. I told Kaggle and then Yahoo. I believe Kaggle has those article data set. I believe those are taken from Yahoo News. That's probably what it is. Okay. So models and platform. So these are different models that I used. I also told before. GCN plus MLP, GCN plus CNN plus MLP, and Deep Graph CNN. Okay. Deep Graph CNN, it's a built-in model inside Stellar Graph library. So it has several GCN and some CNN, and they are using some different sorts of pooling and convolutional 1D. So I tried to utilize that for this prediction. Okay. And GCN LSTM that I wanted to implement are also just using the raw equations for GCN and CNN and try to apply the data and do it. Okay. So no, I didn't reach that far, but in the past years, I had some experience in using equations to implement those models and those anyway. And platforms, you can see, I think the library, Network X, Stellar Graph, NLTK, Y-Finance price capping. So this is what I used. Okay, let's see the results after applying my model on the data, right? So first case means GCN and MLP, right? GCN, some layers of GCN, and then MLP for the prediction, right? Okay, so as you can see, I think you can see this training and validation. This is the mean squared error, mean absolute percentage, mean absolute, and this is the loss functions. They're sort of, I think, validation sometimes followed the training, and sometimes it might have performed a little better, right? So overall, these are the graph and these are the corresponding plot. Let me see, these are taken from the 1000 epochs, and you can see from 1000 epoch, the sequence is actually Pycharm, Spearman, Kendall, Tau, and financial news based, right? Now, financial news based, it performed better in terms of 1000 epochs. It's very similar to the paper. They also found this. Then I can say Kendall, Tau, and in this case, Pycharm looks performed slightly better than Spearman, but Spearman mean absolute percentage error that was better than the Pycharm. So very close. News is definitely the winner than the Kendall Tau, right? Okay, I need to grab some water. Okay, if I used 10K box, below means the below image. Spearman performed better and looks like, I would say news article is still probably overall better. And then Kendall Tau and then Pycharm, right? So there are some variations. So overall I found Spearman and news article that overall worked better for me. But the paper found first news and then Kendall and then Spearman and then Pycharm. Anyway, and my result is not still perfect, right? There are more to do. So another test when I tried graphical convolution neural network, and MLP, right? It is as close as possible I could go to the paper. And you can see validation following training. So, okay, validation training, it looks like there are some gaps. we probably also need to see how far they are in terms of number. Anyway, so if we say 1000 epoch, Pycharm overall perform better. Pycharm Spearman, I would say. Pycharm Spearman, and then probably News, and then probably Candle. Somehow Candle did not work very well for me. So it might be the case that when I used 0.3 correlations, so probably we could not capture the relationships very well. That may be one thing. It might be dependent on the data. If I would be using a different time stamp, or I could say different result anyway. So if I use 15K epoch, I can see that Spearman performed the best, and then probably Candle, probably the Pycharm and News. Those are very equivalent, I would say. Okay, so this is the 10,000 epoch. Okay, 10,000 epoch, I believe News perform better, and Spearman and Candle. Spearman still may be better than Candle. Then okay, so News also works better, like the paper. So it just requires more epoch to reach there. It's just a time consuming. Probably this is the model where we need more time. Okay, third case, deep graph CNN, 1000 epoch. Okay, so third case, 1000 epoch, third case, deep graph CNN, 10,000 epochs. Okay, as I told, it uses multiple layers of GCN and then CNN, and then I added the MLP layer there just so that I can predict. Now, one thing is this deep graph CNN, what does it expect? It expects many different graph as a training, and some different graph, some testing, and some more different graph for validation. So in my case, I have just only one graph. So imitating that was a little bit difficult. So I created the graph. Let's see, based on the 30 stocks, around 15 stocks, I created the training, some for the testing and some for the validation. That's I did it. One training graph, one testing graph, one validation graph. But this ideally expects more graphs and then implement it. So in that case, I had limitations in my data. So I don't expect that I will get a good result. Some alternate approach could be I could use just open price to create a graph, adjusted close price, another graph, and then closing price, another graph. So that could give me some different training graph. Or what I could say, out of all of this 2-year data period, I could just say every 6 month or every 3 month data, one graph, another 3 month data, another 3 month data, another graph. That way I could get lots of training graphs. That could be a good input that it could help. Okay, that is one challenge, how many graphs. And another challenge I found that I think in terms of target variables, right? In terms of target variables, deep graph CNN, okay, it is used. I saw the example cases mostly for the classification. So the target variable usually which class it belongs to, that particular data. Now I found it a little bit difficult to supply the target data. I just tried to do the last step as the target data. That's what I tried. Now eventually, or something similar. So I will not rely on my output. But the thing is, yes, this is a good approach. I believe it has potential. It has potential, and it's a little variations and trying it a different way. So that way, I believe it just worth trying in future endeavors. Okay. I want to do some more comparison between my work and the other paper, right? Let's say, yeah, I already made some comparisons. Now I'll make a little bit more. Okay. So architecture, the paper used this graphical convolution, CNN, multiple, and then MLP, right? In my case, one thing is GCN and MLP. I just GCN and MLP. That is one thing. And another thing, GCN, CNN, MLP. GCN, CNN, and then MLP, right? So that's what I used. I did not use the multiple blocks. I think there are some challenges. I think I'm grabbing this output graph for GCN and then supplying to the next step and then CNN. Yeah, I think conceptually it seems easy, but in terms of coding, it looks like I need to put some more effort and try different ways. Okay, it's not that I did not try. I tried it, but it looks like there are some mismatch in terms of dimensions or data or this and that, and probably the support of the library, how it expects the data. It looks like it may need some more effort. Okay, so probably future work. Okay, my 20 minutes is passed, but I'll go. So, anyway, if I want to do in 20 minutes, I need to shorten some of the aspects. So deep graph CNN, yeah, there are some similarities like the paper, but it's still not, but it probably is more similar to this one. It did not use multiple blocks. I think, yeah, there are some GCN, each one has multiple layers, then CNN and then some other things, or in between some other things, but it did not repeat itself. So it is somewhat there, right? The other possibilities that I considered, but I did not really do it, CNN, LSTM, and implement using equation. That could be some good things to try. Okay. And in terms of making it more closer to the paper, it might be possible to write, rather than using a library, just to write all those different layers using Keras and TensorFlow, GCN, CNN, GCN, CNN. It is possible. It gets a little bit complicated to create those from scratch, all those layers, but it is possible. You might find something along that line. If you search online, you might see some people are trying to do that, but it's sort of complicated, not straightforward. Probably that's what was the purpose of a research work, creating those layers and do something about it, right? So anyway, that itself is a research work. Anyway, let's compare the performance numbers. So this is from the paper itself. This is different my approach, GCN plus MLP, GCN CNN, MLP. And deep graph CNN, I put it here, but I will ignore it. You can see perfection level, but I think it probably, depending on the, I don't have many training testing graphs and other things, the target variable, that probably was not set up properly. So I'll ignore it, I'll compare the others. So if you look at it, let's say the RMSE numbers, yeah, mine is at least 3 times higher. Mine is at least 3 times higher. So it looks like one thing is some architectural limitations is there. It's not exact that architecture. It probably is a less sophisticated architecture. That is one thing. And I believe also I'll need to do more fine tuning. Okay, I think in terms of learning rate that I could optimize, and the epochs, that is one thing, and dropout. And there are some other variations I could do to improve the performance. I think the paper, they did not keep all the, at the side you don't see, right? And it's a small paper. So anyway, I think there are some other things to do to make my models look closer. But I think there's a 3 times, but still we got something. So let's see. So if I want to compare, right? I need to move this so that I can see it. RMSE, the lowest I found news. That's the GCN plus MLP. And then the second lowest is the Pycharm. Pycharm 54.1, that's the GCN plus MLP. And then the Spearman 63.7. No, I think there is a mistake here. It will be Candle, right? 48. It will be Candle 48. So news, Pycharm, and then news, Candle, and news, Candle, and then Pycharm. News, Candle, and Pycharm. So RMSE, right? MAPE, news, Candle, Spearman. Let me see MAPE, news. Okay, 30, Candle, and Spearman, right? but it's a different architecture. But yeah, I think in terms of if we just think about the correlations case, that's how things go. Okay, in terms of which architecture is better, okay, we can say GCN plus MLP in the sense that RMSE is lower, RMSE is lower, MAP is lower, and MAE is also lower. If we just think about the lowest one, then GCN plus MLP performed better than this one. So this is 1000 epochs. One thing is, it might be the case that GCN, CN, and MLP, as you also saw before, that more epochs makes things better here. Maybe more work is required here for that. So this color highlighting, I need to fix that. Okay. So if I use 10K epochs, then what happens? RMSE, news, and then Spearman, and then Spearman. The lowest one is news, and the next one is Spearman from GCN plus MLP, and the next one is also Spearman. Okay. MAP, Spearman, news, MAPE, Spearman, news. Spearman, that's probably it. 31, news, 57. Okay, 57. Spearman, news, Spearman. MAE. Okay, MAE, Spearman, news, Spearman, and then news, then Spearman. That means Spearman, and then news, and then Spearman, right? So, which architecture is better? Apparently, I'm saying GCN plus MLP. GCN plus MLP. RMSE lowest is here, right? RMSE lowest is here. Okay, but GCN MLP, let's see. MAPE lowest is here. MAE lowest is here, right? Okay, if we consider RMSE, then probably I'll say this one. Okay, my perception is RMSE is a better indicator than the others. Especially MAP, we can just give little importance to it. So RMSE wise, this is better, but GCN plus MLP is okay. So yeah, I believe they'll be, I can say overall they're very close. Okay. And in terms of how many epochs, 1000 epochs are usually as good as 10,000 epochs, although 10,000 epochs works better for the GCN plus CNN plus MLP, right? Okay, so in terms of ranking among the approaches, on the paper, news, Kendall, Spearman, Pearson. In my case, I can say that news-based and Spearman are very close. Kendall, Pearson are very close, where Kendall might have performed better a little bit. Let me see what I tried to do in my case. From these figures, I tried to see how many times they came. Probably some sort of number and probably some sort of intuition. And that's how I came back to this conclusion that Spearman cohesion might be very similarly working. Probably cohesion has a slightly upper edge, and then Kendall Pearson can be equivalent or very close, but usually have lower performance than the cohesion and Spearman. Okay, what was the challenges when I was trying to implement this? Finding the exact data set, because the paper did not give the exact data set, did not give a link. I needed to find out. And also I tried a different data set that was difficult to work with. I think manipulating and fixing and finding the right things was sort of difficult. Okay, if you check my GitHub, I think all the code and all the data will be there. I think it looks lots of effort were there. Eventually, I did not use that. And then use Y-Finance to grab data, but still I did not get data for two stocks. But I think ideally I could go to another finance site and I could grab those data. So, and implementing exact architecture, one thing is it's tricky to implement. how I fit together and make multiple blocks. That is one thing. Another thing is from my reading of the paper, understanding the paper, I need some more details to make the exact architecture that I really did not find. And I think I did not see any code or data released by the authors that I can get some ideas, some close ideas. So yeah, the platform, yes, I think if I could get a faster platform, I could probably do more experiment to get the result. Anyway, so adapting data for deep network, I think this probably is the one of the most challenging part. All the data and adapt it or reformat, reshape it in such a way that it is correct and also fits the model. It works there. Okay. So challenges, yes, limitations also has relations with the challenges. I think the workshop for IFT, it has some limitations, right? So because my goal was to imitate the paper, so the exact implementation is not there. So that I would say one limitations. Another thing is my goal was to do something similar or to extend it so that I can get better performance. As you saw, I got some performance, and in some experiments, yes, the prediction seems consistent with the pricing of the stocks, but it needs to be more perfect, right? In some cases, I saw that the predicted prices for all of the stocks had the same output, same predicted price for all of the stocks. Now, one thing is, I think from my research, I saw that this can happen if there are too many connections between these stocks in the graph. So finding a balance or using a correlation marks that give a balanced number of connections that probably could improve the result, and probably epochs. And I believe I changed some other things that actually helped me to avoid that thing. Anyway, so news data set, yes, I used only 15,000 rows of articles, 15,000 news article, but the paper has used 1 million. So there is something to improve for there for sure. And future work definitely address those challenges. And also the paper also has the same problem, exploding gradient problem to resolve it. I believe I'm using a similar architecture, so the same problem can be there and I could improve it. Okay. This is some references. Now, I hope that you enjoyed this presentation. And if you have any questions, I'll be happy to answer. Thank you. Have a good day. Bye.